Hello dear students, I am Rajendra Verma and today we are going to discuss on fluorescence spectroscopy, photomicrography, video spectral comparator, electrostatic detection apparatus and determining the age of documents. This chapter is divided into 5 modules. Module number 1, fluorescence spectroscopy, module number 2, photomicrography, module number 3, video spectral comparator, module number 4, electrostatic detection apparatus and module number 5 is determining the age of document, followed by the conclusion. When light from an exciter source is fallen on the surface of an object, the energy is either absorbed or reflected. Selective absorption and reflection may also be occurred. In selective absorption, substance absorbs the light to certain wavelength and rest of the light is reflected. This phenomena is depending upon the properties of the substance on which the light is fallen. It is also possible that object may exhibit photoluminescence. This is the secondary radiation. This radiation possesses lower energy and the longer wavelength as compared to the light of exciting source. Fluorescence may be considered as interaction between light and material. Fluorescence is an emission of light of certain wavelength. The resultant emission spectra are highly characteristic and provide quantitative and qualitative information about the compound. In a simplified atomic model, in normal condition, the electron remain in their original orbit, but when external source of energy stimulate them, they absorb and jump out in the higher energy orbit. The electron has tendency to return back to original orbit. During return journey to their accustomed orbit, electron releases excess energy in form of radiation. This phenomena of absorption and relaxation of external energy causes fluorescence. The fluorescence is ceased as soon as the external energy source is removed. It is an instantaneous phenomena. Contrary to this, some substance when exposed to light of the certain wavelength, they store energy for a time. The energy captured by them will not be released immediately and completely. The radiation ceases will persist for certain period and gives glow. It is a delayed phenomena and known as phosphorescence, but it has less diagnostic importance in examination of question documents as compared to the fluorescence. In handwriting science, it is well known fact that no two signatures have exactly similar information. Similarly, in field of spectroscopic analysis also, it is an established fact that no two compounds have the similar fluorescence. This characteristic chemical quality of substance provides analytical tool for scientists to identify the particular compound. Specific compound has specific fluorescence, which forms characteristic spectra. Some compounds which have fluorescent property such as aromatic hydrocarbons may be characterized by the spectroscopy methods. The fluorescent compound shows peculiar spectra and can be classified into 2 categories. Category number 1, absorption or excitation spectra. Number 2, emission spectra. Absorption and emission spectra are peculiar to particular compound due to its high identifying ability. These spectra are referred to as a compound's fluorescent signature. The device which measures the fluorescence and its data is called fluorescence spectrophotometer. It is a highly specific technique for quantitative and the qualitative analysis of chemical compound. This technique is widely used in field of research, biochemistry, medical, forensic, industry and pharmaceutical companies, etc. The contribution of fluorescence spectroscopy is quite valuable in field of analytical techniques. In experiment of question document, this technique is also found instrumental for analyzing the ink and differentiation between two inks. This technique often proves conclusive and give the definite results. The spectroscopic findings are quite convincing and usually believed in the legal domain also. The property of fluorescence is occurred by polyatomic fluorescent molecule which is known as fluorophores. Fluorophores are the component in the molecule that causes fluorescence. Ultraviolet fluorescence. Ultraviolet radiations play an important role in forensic examination of documents. Security documents have significant covert features. Such features are produced authenticated images while examined under the UV luminescence. Infrared luminescence. When a halogen lamp, you can say the blue light, is used as the radiation source and shone onto surface of an object, it exhibits IR luminescence. This is invisible for naked eye, but it can be seen by using the proper filters. It is useful in analyzing and characterization of ink, dyes and pigment. Applications. Fluorescence spectroscopy is a sensitive, reliable and scientific technique for characterizing the molecule environment and events. Diagnostic importance of fluorescence is utilizing in field of medical, biochemistry, forensic, industries, academic and research areas. In examination of forensic document, it is a reliable tool. Fraudulent addition, alteration in genuine document by different writing instrument can be detected. Latent fingerprints can also be successfully visualized. Fraudulent addition and alteration in genuine documents by different writing instrument can be detected and characterized by using the fluorescence phenomena of component of different ink. It is a useful tool for qualitative and the quantitative analysis of chemical compounds. Image of very tiny object captured by photography with the help of microscope is called photomicrograph. Technique to get the photographs or digital image of a tiny object using a microscope or similar device is known as photomicrography. It is quite different from the classical photography. It requires photography skill, scientific knowledge and sufficient experience in the field of photography. Person should be well conversant with the principle and the procedures of the microscope and cameras. Microscope open new horizon for mankind as well as in scientific domain. Many academic studies and research are taking shape due to the microscope. Study of tiny objects and activities in the field of medical, microbiology, industry, engineering and forensic science, etc., photomicrography becomes an important need. Association of microscope with light arrangements provide invaluable contribution in different areas. Taking the photomicrograph is quite simple. Place a camera on a microscope with the proper attachment, lighten the object, duly focus the object and click. Capturing the image which is observed in the microscope onto the photographic film is an important step of photomicrography. This photomicrographic image will be kept in a form of hard copy. These photographic outcomes are preserved in the form of permanent record also. Photomicrograph can be taken in both black and white as well as in color option. Color photomicrography is rather complicated as compared to the black and white photography. The film of color photomicrography is coated with special emulsion. In examination of fraudulent document, symptoms of forgery is generally remained invisible in normal eyes. Detection of these symptoms are significant and necessary to identify the forgery. Many overt and covert features of security paper are revealed by this technique. Our eye is able to see the objects well within the visible region of electromagnetic radiations. Visible light waves are ranging from 400 to 700 nm. The visible spectrum has 7 colors ranging from violet to red. Beyond red, infrared wave of light exists, following by the microwaves and the radio rays. Similarly, on the other end, the electromagnetic spectrum beyond the violet region, ultraviolet waves region starts. This region further includes X-rays and gamma rays. Light waves extended beyond the both ends of visible region of electromagnetic spectrum are invisible to naked eyes. But with the help of special equipments, one can able to see the results in visible region. In routine, our eyes are enough capable to see the object and activities around. But for minute and in-depth examination of object, we need scientific aids. In forensic examination of documents, many inconspicuous vital clues are remain unnoticed by the unaided eyes. For study of various properties, characteristics, function and behavior of the substance, some special equipments are required. In question document examination, equipments having good range of light source and the magnifying facilities solve majority of problems. Video spectral comparator is state of the art equipment which provides a valuable help in forensic analysis of documents and its ingredients. VSC is an abbreviated form of Video Spectral Comparator. It is a PC based imaging system. VSC has a series of equipments. The latest and upgraded version is known as VSC 8000. This VSC is suitable for almost all type of problems encountered during document examination. Equipment. VSC has a box shaped main unit. A high resolution camera is placed on the main unit. The camera has sensitivity approximately from 350 to 1000 nm. This unit is also associated with the set of filters, different light sources and transmitted light panels. The light source is placed underneath the panel which illuminated the document. A 30 inches screen is attached with the main unit. A window based PC system is also associated with the machine. VSC works with the live image. This live image can be saved and again compare with this another live image. VSC has a auto exposure which automatically control the iris opening. Operator can control over focus, magnification and zoom. Side by side comparison, spotlight view and transmitted light examination may also be carried out successfully. Light sources. VSC has a different light sources. The incandescent light filament lamp ranges from 400 to 1000 nm. The range covers visible to near infrared light. These lights are used when one intends to utilize the function of flood, transmitted, spot and side light. The LED lamps which have light range from 400 to 700 nm are available coaxial and diffracted light facilities. For different illumination, one has to choose the proper filter for better result. For ultraviolet imaging, one has to select proper UV radiation for excitation to get proper fluorescence. Examination of document using narrow band illumination produces fluorescence in IR region above 800 nm. It is useful for ink and dyes examination. Inks examination under infrared radiations give characteristic fluorescence in visible region. For illuminating the document from different angles, diffraction light is used. For side light examination, this equipment has two lamps fitted at the left and the right end of the document plate. These lamps provide broad band illumination. Document can be viewed under the light of lamp. Lamps may be used for examination from one side at one time or from both sides simultaneously. Visualizing invisible security features, coaxial light is used. This light is shown perpendicular onto document. VSC also offer a range of filters. Selection of proper filters in camera and lamps gives a better result. Filters are useful in allowing or disallowing certain wavelength of light to make the view clear. VSC provides facility of microspectrometry. The spectra exhibits the light intensity and wavelength. The range of wavelength is ranging from 400 to 1000 nm. The four types of spectra graphs have been produced, that is reflectance, absorption, transmittance and fluorescence. Spectrometry provides valuable evidence in many ways in forensic examination of document. A document examiner often comes across with the problem where the document is seized from the scene of crime looks blank. No writing, signature or marks are noticed. On careful examination of such document, especially in oblique light, some writing strokes are visible, but text often remained unreadable. All efforts usually go in vain when the indentations are faint and have light writing impressions. In most of the criminal cases of such exhibits pose a challenge to document examiner to visualize, analyze and identify the indented writing. Before going in deep regarding visualization of indented writing, let me ask you a question. What is indented writing? Or what do you understand by writing impressions? Simply, the impression of writing appear on the paper which is placed below the top sheet is known as indented writing. I am sure you have noticed that during the process of writing, we exert some pressure through the writing instrument on the paper. This causes pressure mark on the second sheet. This writing pressure marks are called indentations or writing impressions. Visualization and identification of indented writing provide great help in investigation. It is a useful evidence for prosecution and tenders and valuable assistance to judiciary. ESDA is an accurate, sensitive and compact equipment. It is a non-destructive technique which causes no damage to evidence. This is a physical electro concept for detection of indentation. The difference between the charge of the pressure and non-pressure area on the second sheet is played a key role in visualization of writing impressions. On suction, the charging film is adhered with the plate. The top surface of film must be electrostatically charged. Use high tension corona wire for better results. It is evenly distributed electrostatic charge in the air above the surface of charging film. On application of toner, the negatively charged toner particles are attracted to the area where the indentation lies. on the paper. Once an electrostatic charge has been applied to the charging film, the latent indentations are developed. Application of toner. Some ESDA has arrangements of spray over the charging film. A specially designed chamber is placed over the plate. A nozzle is fitted at the corner of the chamber. On command, it sprays fine toner on the surface of film. An appropriate amount of toner should be sprayed, then wait for some time to settle down the toner completely and evenly. Brush method. In some cases, magnetic brush is used to spray the toner. This is a manual process, required time and patience. This is a tedious job, but good for the selective development of the indentations. Photography, scanning or recording of deciphered and the visualized writing can be done, which provides significant help in handwriting analysis and maintaining the record also. It is true that majority of cases relating to document examination have problems pertaining to identification of handwriting, but few cases are concerned with the age of document. Determination of age of a particular document in some cases plays a key role in its verification. It gives a vital evidence to investigation and judiciary that a particular document is as old as it claimed or it is prepared in recent past. Determination of age can be done in three bases. Number 1, analysis of ink. Number 2, analysis of paper and other ingredients associated with paper. And number 3, study of phenomena of simplification in writing. As you know, ink has a chemical composition. Chemical substance, when exposed with atmosphere, it oxidized. This oxidation causes fading in color of ink. The fading of ink, when compared with the standard record, or you can say the reference library, can give an estimated idea about the age of document. Spectroscopic analysis of chemical components and association with documents provides clue about the age of the document. It is fact that the exact age of the document cannot be determined. Similarly, the use of certain writing instrument in the disputed writing becomes significant in age determination. For example, ballpoint pen came in India in 1945. Claim over a document contains ballpoint pen writing before invention of ballpoint pen that indicates towards fraudulence. Analysis of pulp and chemical substances used in paper making also have date significance. Association of certain ingredients with the paper is kept in record by paper industry.